Welcome and thanks for joining today's presentation on the Smithsonian Institute's Changing Landscape Initiative. My name is Brian Fainer and I'm with the National Park Service and help support our Connected Conservation effort. The Connected Conservation webinar series focuses on how NPS staff and partners can use various tools and strategies to conserve NPS resources at the landscape level. Working with gateway communities outside of parks is critical to landscape scale conservation. And as such, our webinar series is exploring the numerous opportunities to partner with communities to further conservation. You can register for future webinars in our series and view past recordings by going to the Network for Landscape Conservation website or our internal National Park Service Connected Conservation Toolkit. And links to both of those sites will be posted in the chat box. We will post a recording of today's webinar following the presentation. And throughout the presentation, feel free to plug in questions in the questions box. We'll look at everyone's questions following the presentation. As a reminder, our webinar series is open to federal and state agencies, nonprofits, and other conservation partners. So feel free to invite your colleagues to future webinars. Today we have two presenters from the Smithsonian Institute with us today. Yada Locker leads the Changing Lands Initiative and is based at the Smithsonian Conservation Biology Institute in Front Royal, Virginia. Since the inception of the Changing Landscapes Initiative, Dr. Locker's team have connected with over 100 stakeholders and developed rich collaborations with researchers, planning groups, and communication experts, and land managers with diverse backgrounds and expertise. Carlisle Howard is the communications lead for the Changing Landscapes Initiative. And among other things, she travels across the Changing Landscapes Initiative's 15-county region of the Northern Shenandoah Valley and Blue Ridge region of Virginia, communicating the value of the landscape, how it is changing, and how the initiative can support planning for the future of the region. So with that, Carlisle and Yada, the floor is yours.
Thank you, Brian, and thank you for the opportunity to give us this platform to come and talk about our work. I just wanted to give a little bit of background on myself and then pass it on to Carlisle. I began this project, like most of us in conservation, because I have a lot of interest in protecting the landscape and species for future generations. I myself find intrinsic value in that, but sometimes that is not enough to convince planners, policymakers, and change makers to integrate science into their decision making. So that's why I joined Smithsonian in 2015 and have been pulling together this program over the past 5 years. So we're going to give you a very broad summary of what we've been up to. And now on to Carlisle.
Okay, thank you so much, Yada, and thank you everyone for logging on to hear about the Changing Landscapes Initiative. That's CLI for short. So really quickly about me, I'm the communications coordinator for CLI, and I've been with CLI for a few years now. Very quickly, I realized that at the end of the day, conservation is a people problem. So personally, I was convinced of this by seeing that when CLI was able to increase its capacity for communications, we started to really build trust and visibility in the community, which led us to having a far greater impact. It was a cause and effect. So I believe that we have to employ our best storytelling, marketing, behavior science, and psychology in our science and conservation communications in order to succeed. So that's kind of where CLI and I align in our goals. And we're here because we think we can provide value to the work it is that you all are doing. So from increasing our capacity to conduct landscape level outreach and collaboration, to developing a model that unifies science and community values in an integrated conservation approach, increasing our capacity to conduct democratic, scientifically backed, cross-jurisdictional conservation, a way to determine the impacts of change to parks, and then finally, a way to communicate the tangible value of parks to the surrounding people and to the surrounding communities. So really quickly, one sentence statement, the Changing Landscapes Initiative produces science on the potential impacts of land use change on local landscapes. So these are the kind of groups that we work with, from county planning to committees, conservation groups, universities, public lands advocacy. We work with all of these kinds of groups. So this is our mission. And essentially, in places that you know are changing or where you know change is coming, it is so crucial to understand what's going on and how that is going to transform the land. So that is our role as CLI, to produce this kind of science through an approach that integrates communities, conservation groups, rigorous science from many groups, and strategic storytelling and communications. So again, we're a team working to understand the impacts of land use change in a place that is rapidly changing. So this is CLI's pilot study area. It's the Shenandoah region highlighted in light blue. This is a place that is rich with biodiversity, productive farmland, and there's lots of development fast approaching from DC. DC is that red star there. So you can see all of that light pollution and development just spreading into our region, all of that change that's happening. The thing is that most land use decisions here are made without much of an idea of how they're going to impact this area's natural resources in the long term. And that's why it's so important that we bridge the gap between science and communities here, and of course, everywhere. We work closely with local communities here to produce science that's relevant to the decisions that they're making right now. We communicate to the people here that our land is changing, why we think that's happening, and again, how that change could impact the natural resources here. This is our pilot study region. It's a 15-county region surrounding the Shenandoah National Park. That's the Shenandoah National Park right there in dark green. So you can also see DC in that blue star. So we're right next to DC. We like the culmination of 3 really important watersheds, lots of tributaries to the Chesapeake Bay, and right next to the Chesapeake Bay as well. This is our landscape's composition in terms of the 4 land use categories that we study. So forest, grasses, crops, and development. We study the transitions between these 4 land use categories. And I think it's important to know that we don't just study the transition from, forest to development, or grasses to development. Because although development, yeah, it's the most visible and impactful land use change, it's the transitions between all of these land use categories that tend to happen over time and right under our noses. And that has a huge cumulative impact on the landscape. So we study the transitions between these 4 land use categories, how much of it is happening and where that change is happening. And we study that impact on ecosystem services. So from clean air and water quality to access to parks and green spaces, to scenic beauty and just general quality of the land, all of it which is underpinned by biodiversity. So we study both of those, the impacts to ecosystem services and to biodiversity. Ultimately, we look at how all of this change that's happening and how the land use decisions we're making today could impact all of the things we're going to care about in our home tomorrow. So we know change is happening and we know growth is coming. What we don't exactly know is where, what it's going to look like, and how we should plan for it. Moreover, land use decisions here and in most places are highly controversial and politicized. That's why one of our main goals is to serve as an objective resource of scientific information on how our decisions could actually play out on the land. So how do we do that? What can we do as scientists to support planning for the future of our home? So we chose an approach that allows us to take science off the shelf, an approach that brings together people and science. We chose something called scenario planning, which is where you can bring together that scientifically rigorous component, combine it with community wisdom to develop these scenarios of the future for this region. So this is called scenario planning. What exactly is scenario planning? In its essence, it's a strategic planning method, and we use it to make flexible, long-term plans. It is a process for dealing with uncertainty, so when the future is uncertain. You likely use scenario planning all the time. And as a really simple example, okay, you're throwing a barbecue party next month at a park. This is very hypothetical at this point, but imagine you can throw a barbecue party next month at a park. But you don't know whether or not it's going to rain, and you don't know how many people are going to show up. But of course, you do have to plan for whatever happens. So you do scenario planning, whether it's in your head or on paper. And if you were to put it on paper, it would look kind of like this. You take your two most uncertain and impactful variables, weather and turnout of people, and you set them on an axis. So at each intersection of the axis, you have each scenario, and you have to come up with a plan for each one so that you're prepared if each one were to happen. So for example, what are you going to do if it rains and a lot of people show up? It's probably important to have a plan for that. That's scenario planning at its most basic level. So what exactly are scenarios? Scenarios are just carefully constructed snapshots of the future and the possible ways that a situation could develop. When is it helpful? When decisions and their outcomes are uncertain, when the future is uncertain. Scenario planning is just a structured way to do what I just showed you on a big scale. It has a long history of application in military, in corporate strategy, and in land use planning. You know, when the future of a certain industry or a future landscape was uncertain. So CLI uses scenario planning in order to bring people together to convene for a shared vision of the future. We use it to communicate change on the landscape, and we use it to communicate the value of the landscape to the people that live here. We use it to reveal relationships between land use change and ecosystem services, how our decisions could really impact the landscape. And finally, we use it to evaluate the resilience of our current policies and to support the development of policies. So what's the first step? Well, our first step was to build a comprehensive scientific foundation. And that meant bringing together about 40 plus scientific experts, historians, social scientists, to build this foundation and to answer a few questions with far more specificity. Like, what is it that people here really want to protect? How exactly can we measure change on the landscape? And what exactly is driving that change, and how is it driving that change? So just as an example, these are a lot of the drivers of change on our landscape that we studied and integrated into the scientific model that Dr. Locker is going to show you in a bit. From topography to population, income, energy demand, climate change, soil and geology, all of these things went into this scientific foundation. So step 2 is to actually build out these scenarios of the future with 40 plus community leaders. So that means heads of conservation groups, county planners, even just influential members of the community to come up with these scenarios. So in a workshop setting, we had them look at all of the drivers of change on the landscape, and we had them pick those 2 most uncertain and impactful drivers of change on the landscape. And they determined those were population growth and the political will to actually plan this region strategically for the future. And then at each intersection of this axis, you get a scenario that then they built out with narratives, pages and pages of narratives about what each future would actually look like and why. So this is what those scenarios look like on an axis. Again, these are scenarios for 2060, so at this point in 40 years into the future. And each scenario comes with pages and pages of a story about that future. So I'll go really quickly into what each one is. So this is the first scenario. This is a high population and a high political will scenario. So development is going where we want it to go. It's going around urban centers. We're maintaining strong economies and local identities, local culture is strong. We're concentrating our infrastructure, but we're rejuvenating our forests and our ecological resilience. As opposed to a high population but a low political scenario, where development is happening along roadways, land is becoming expensive and fragmented, meaning that our ecological resilience, water quality, recreation, forest, they all suffer. So these are both the two high population scenarios. And then we have the low population scenario. That's a lower half of that axis. This is a low political will scenario where the most meaningful use of the land is resource extraction and absentee land ownership. So we just have an overall lower demand to conserve our natural resources with the lower population. And then we have a low population but a high political will. So yes, younger generations are moving away towards urban centers, but we strategically plan for that so that we can preserve what we want, which is open space, connected forests, so we can continue to provide water, outdoor recreation, agricultural products. So I want to make clear that it's not that our goal of the future is going to be one of these. In reality, we're probably going to end up with a combination of many of these possibilities with features from each scenario. Scenarios don't predict the future. They're tools to help us explore different ways the future could unfold. They're tools to help us form a shared vision of the future, develop strategies, and create high impact policies that can be implemented right now. So I'll give you an example of how we do that. So this is traditional predictive planning. This isn't what we're doing with scenario planning. This is what we typically tend to do. So we assume the future is much like the present, but it's not possible to predict the future. We just tend to plan for what we think is most likely to happen. But there are so many things that have happened on our landscape within the last 20 years that we could never have predicted, which means that we're probably left unprepared for what's actually going to happen in 20 years. Alternatively, in scenario planning, what you do is you envision these plausible futures, and then from there, you can identify the decisions, the red flags, important organizations, or even people that exist along the path to each future. So you can reveal these paths and what could result from taking each one of them. Then as you move through the future, you use what you've gleaned during the strategic planning process as guide for decision making. Okay. Now, this is why it's so crucial that our science component is really strong. We chose this approach so that local communities, through this process, could guide our science. So the science we're then going to produce, well, that we have produced, allows us to understand what drives change on the landscape. It helps us understand the relationship between land use change and the impacts on natural resources so that we can improve our ability to make ecologically informed land use decisions. So how do we put these two together? How do we put these scenario stories together with our science? We developed a model that projects or simulates what each scenario could look like in terms of land use. So we translated each scenario into a map. So I'm going to show you what those look like. Exit out here. Okay. So this is what that looks like. This is our study region here as it is right now. Just as a marker, you can see this is DC right here. This is Shenandoah National Park right here in green. So all the green that you see is forest. All the yellow that you see is grasses or pasture. The red is crops, and all the gray is development. So this is as it is right now. And when I move this wand, you can see what the model simulates in a high population, low political will, or reactive planning scenario. So I like to do this big picture first. You can see big patterns of change from this level. So best is to keep an eye on like this area spreading from DC. And then when I move the wand, you can kind of see where change is happening, where it jumps to. And then of course, this is really big picture. But then I really like to zoom in here to a county. This is just one county, 2 counties away from the Shenandoah National Park. And this is a place called Fauquier County. So Fauquier County, mostly the northern end is all under conservation easement, but the southern end, as you can see, all that red is crops. It's either crops, forest, or pasture and water. And that's how it is right now. But when I move the wand, it shows you in a high population, low political will scenario, what the projections are for 2060, just 40 years. So you can really see how that development just explodes in this county. You know, and then, so all that gray is development, and then you can compare it to, this is when I move this wand, it shows you the projections for a high population, so the exact same amount of population, but a high political will scenario. So that's the same amount of people. It's just where we're placing that development. So again, I'll compare the two. And here. So one of our main messages is it's not exactly how much change is happening or how much population you're absorbing, but it's where you place it that matters. So I'm going to return to the presentation here. And I'm just going to show you the result of one of our collaborations with a group called Nelson Bird Woltz. They're a very ecologically minded landscape architecture firm based out of Charlottesville. So as you can see, our model depicts a lot of change, a massive amount of change, really, depending on how we're planning for the future. But the thing about maps is maps can be tough because they're not super emotional. And if we're using these to connect with communities, we have to connect to their sense of home and their sense of place. So, you know, maps aren't emotional, but pictures of where you grew up are. So we wanted to connect our maps and projections of the future to that sense of home and to that sense of place to make the future feel real. So what we did was we looked at the model to look at where the most change was happening, depending on how we were planning. And then we cross-checked that with where is the best opportunity to affect change at the grassroots level. And in our world, that means a comprehensive plan renewal. So where we landed was a county called Rockingham County. That's a home of Harrisonburg, James Madison University, and they're actually going through a comprehensive plan renewal this year. So we talked to conservation groups there, and they helped us. Well, it was a conservation group called Alliance for the Shenandoah Valley, and they helped us settle on a view that they thought would resonate most with people's sense of home there. And that's this view here. This is looking out into the Shenandoah Valley off of Massanutten Mountain. And this is the view as it is now. So we had designers edit the view according to what the model predicted the view would look like, depending on what we do. So if you look, you're looking out into the view now. This is what that view is projected to look like in a high population but low political will scenario. So we're reactively planning. We're reacting to the change that's happening, which is pretty striking. But if you keep looking out into that view now, this is what the model projects in a high population but high political will scenario. So Alliance for Shenandoah Valley and other conservation groups take these out as tools to get people involved in planning and to wake up to the fact that, you know, we're at a fork in the road. And both of these futures are entirely possible depending on what we do right now. So I'm a big proponent of the fact that powerful visuals at the right time and at the right place, connected with the right people, can affect change. So I'm going to pass it over to Dr. Locker now to really get into the specifics of the model that she developed and the impacts that we've gleaned on ecosystem services.
Thank you, Carlisle. So I'm just going to give you a very broad overview of some of the impacts of this land use change model on ecosystem services and those metrics of biodiversity and function. So our scientific approach involves several components. understanding the current landscape, quantifying historic change, uncovering primary drivers of change, modeling future land use change, and then now, at this point in the presentation, I'll be showing you how we would take that in order to evaluate impacts of land use change on ecosystems. And this is the one of the benefits of scenario planning, where we can incorporate the uncertainty about the future and put it in a strategic format where we can utilize it in planning. So again, everything comes down to this equation. This underlies our thinking with regards to the impact of land use change on biodiversity, ecosystem function, and services. And that is the composition, or how much, plus the configuration of where. That's really what communicates us what kind of function this landscape could have. So we applied our land use change model across each of these ecosystem services: water, change in viewshed quality, the risk of habitat degradation, carbon, and crop pollination. We used a few different methods and platforms, including the Chesapeake Bay model, FACET, and INVEST. We ran this across all 5 scenarios to get future projections and change estimates. So some of these that I'm going to show you are further along than others. Some are completed, and some are just starting. So first, crop pollination. I'm going to go through these really quickly. We estimated the pollinator visits for each location. We got estimated pollinator visits for each location, and we got estimated abundance of bees nesting at each particular location. Our inputs for this model were nesting suitability and foraging resources by land cover type. And then we did this by species. So we got flight distances, nesting preferences, and seasonality as inputs into the model. The next component is carbon. From this model, we received estimated total carbon comparison between years equals the amount of carbon sequestered, and also the estimated economic value of the sequestered carbon. For this, our model inputs included land cover type, carbon stored above and below ground, in the soil, and also dead matter. Viewshed quality was another ecosystem service that we evaluated. We got the change in viewshed quality measured as % non-developed for approximately 1,200 key nature viewing locations. For each location, we have the % land cover type within that viewshed. So the model inputs for this were Flickr pictures taken off of the internet and using the tag on the location. So something that would lead us to believe that this was a picture that had to do with recreation or habitat or outdoors. And then we used what could be seen based on the elevation from a digital elevation model. Next was habitat quality. We estimated habitat quality for forests, grassland, and urban. And our model inputs for this were rasters of threats. Threats in this case would be different types of land use types. Here it was limited to land cover types across a 50-year window. And we also used inputs with regards to how far a threat would permeate a particular habitat, given our understanding of that land use. And the last ecosystem we looked at was water quality. We had 2 active collaborations on this, one with Virginia Tech and one with the USGS. We got several different metrics from our water quality ecosystem services assessments for floodplains and stream banks. They included nutrient fluxes, erosion, and accretion of sediment, and also the structure of sediment within the stream beds. All of these were important for either, human health and well-being, drinking water quality, or the ecosystem health. So this is especially important here for us because of the Chesapeake Bay. So TMDLs, I'm sure most of you know what this is, but it's a regulatory term in the U.S. Clean Water Act that describes a plan for restoring impaired waters and identifies the maximum amount of a pollutant that a body of water can receive while still meeting the water quality standards. In the case of our models, any small increase in the scenario would work against the goal of decreasing TMDLs by these amounts here on the slide by 2025. So here's an example of some of our results created through collaboration with Virginia Tech. This was done at a geographic unit called a land-river segment, which is the intersection of a hydrologic unit and also a county or municipal boundary. So here, the primary message is essentially that land use planning ended up being more important to water quality metrics like total nitrogen than total population growth. So this is really getting to that, the slides that Carlisle was showing, where it's about where the change happens. Strategic planning could include the same amount of population growth, but depending on your strategy, you may result in very different outcomes. We also collaborated with the USGS to get higher resolution estimates of impact. This provided information at a scale that was more accessible by those making on-the-ground local conservation and planning decisions. So an interesting aspect of this is how tree roots were used in the analysis. The exposure to the atmosphere and the change in support from surrounding or lack thereof soil causes anatomical changes at the cellular level, which actually allows us to identify the timing of root exposure. This kind of information, combined with Facet, an open source Python tool, maps the floodplain extent and derives reach scale summaries of stream and floodplain geomorphic measurements from high resolution digital elevation models. So again, this was a much more higher resolution assessment of water quality change across our scenarios in the future. So here's just an example of some of our outputs from the USGS study. This is for high population and strategic planning. This is change in horizontal stream bank erosion. So this is what you would actually see if you were walking along a creek. This is the erosion in centimeters per year between 2011 and 2061. So higher amount of change would be the red, and then lower would be blue. So this is strategic again, this is reactive. Just going back and forth between the two, and you can see the impact of different strategies in terms of planning for development and population growth here. All right, our next piece, we also needed to evaluate the what underpins the production of those services for the long term. So we understand that biodiversity and ecosystem function are essential to maintain if we want to continue to have these ecosystems produce these services that are necessary for our quality of life as well. So this section will summarize some of our work in relating land use form and configuration to biodiversity and ecosystem function. We're really exploring analyses around the concept of ecological integrity. Ecological integrity we define as the ability of an area to sustain biodiversity and ecosystem function in response to human impact. We think of this in terms of this formula. The composition and configuration is what really equals landscape function. And why is that? Well, rapid change is happening. We need landscape scale assessments of this impacts of this change, because change is large and we need to contextualize it in context of other land uses and how other people are making planning decisions. And we also need rapid and assessments that are good enough so we can start making conservation decisions now. One component of this work is an evaluation of forest fragmentation. This is currently ongoing. This is a secondary analysis of our land use change model outputs. We are looking at metrics of pattern and configuration that we can conceptually relate to ecosystem function. So despite the landscape of northwestern Virginia that shows it's over 55% forest cover, only a third of that forest is actually within public protected lands. The remaining forest cover actually occurs outside of this in private lands. So when we look at the net forest change with and without protected lands, we found that more than 73% of those changes happen outside those protected lands. Now we're talking to the National Park Service, where obviously protected lands are what national parks are all about. But it's, again, all within context. So change that happens outside of these protected lands can certainly impact the ability of that park to provide services to people, and also the quality of enjoyment and recreation that the park does provide. So these two figures here just give you an example of loss and gain for forest change outside protected lands for 3 different land use types. That would be the cropland in orange, development in gray, and grassland in yellow across all of our 5 scenarios, the business as usual, and 4 alternate scenario realities for a 50-year timeline. The second figure here is just an example of the second component that we care about, and that is not how much, but where. So this is giving us an idea of, could we use hotspot analysis in order to identify the most significant clusters of loss? This kind of analysis will allow us to locate areas where observed patterns are not likely the result of random processes, and therefore they could represent places where there are underlying spatial processes at work that are important for us to pay attention to. In this figure here on this map, you can see that on the upper right-hand corner, that's that area of high population growth and development that Carlisle was pointing out in our land use change maps, and that's nearby Washington, D.C. and Baltimore. You know, that's really important to consider. We want to be able to protect habitat where people can have access to it and nearby population centers, but that's not the only kind of change that matters. This slower rate of change in the blue areas between George Washington National Forest and Shenandoah National Park on the lower left-hand corner of that map really illustrate places where we need to be considering what potential future change could look like. And can we act now in order to preserve habitat and ecosystem function in that region ahead of a scenario where we're ending up having to act really quickly in order to prevent significant loss? So the next component we looked at was mammals. This is a completed study. It's been published already. We used wildlife camera traps at 1,591 locations along a large-scale urban to wild gradient in Northern Virginia. We used occupancy models in this analysis, and we focused on 5 representative species that were divided into 2 groups, those that are sensitive to human impact and those that are synanthropic, or could benefit or do okay living around people. So from those 15 species, we got those 5 representative species, and we looked at the distributions of those classes between the scenarios. So what we found is that the distributions of sensitive species did not shrink drastically under any scenario, whereas the distributions of synanthropic species increased in response to anthropogenic development. But the magnitude of these responses really varied based on the projected rate of human population growth. So this is likely because most sensitive species are dependent on large public protected lands in the region, and the majority of protected habitat losses should occur in non-protected private lands. This really illustrates the importance of public protected lands in mitigating range loss due to land use changes, and also the positive potential impact of strategic planning in further mitigating mammalian diversity loss in private lands. Next component that we looked at is invasive plants, and we're just reaching the end of this analysis this year. So as most of you know, invasive plants are responsible for degrading the function of forests and other habitats worldwide. They're a massive problem. What we did here was a study to understand the role of broad landscape features on invasive species presence, and also to examine the utility of using species distribution models when you're considering the best available information on the presence points of species compared to detailed field surveys. So we don't always have the ability to go out and conduct detailed field surveys for every single species we need to understand. This study was put together in a way to allow us to assess landscape scale variables and evaluate what's the potential risk of establishment of invasive plants within forest patches of different kinds of forms and configurations. So what we found here was that the amount of non-forest land use in the surrounding landscape showed the strongest relationships with invasion risk, but varied by species for what land use was the most significant variable. Here's just an example for one piece of what we've found in this model. This is for Japanese honeysuckle. So what we found here is that the risk intensity, and that's that y-axis, the relationship with distance to nearest grassland, actually decreases. And this map on the right just is projection of that information total for Japanese honeysuckle. So it's distance to nearest grassland, cropland, percent composition of each of these, percent, or distance to development, etc., all together, and gives you an output across forest patches in our entire study area. So together, these results can highlight the higher risk of invasion posed by areas with high levels of forest patch fragmentation, regardless of the land use filling the fragmentation matrix. Our next example, we are at the beginning to middle stages of evaluating bird communities across the same landscape. So birds all over the world are experiencing steep declines. This Changing Landscapes initiative has been collaborating with Virginia Working Landscapes, which is a Smithsonian-based NGO, and we're trying to develop a quick assessment method for bird abundance by looking at different landscape matrix. So not all species will respond the same way to the landscape configuration. We're looking at two approaches. This here is the evaluation of preliminary results for the grasshopper sparrow. And what we found is that the increase in grassland in a total percent within a 250-meter radius of our sample points was a strong indication of where we would find this bird. So as some species, however, were rarely observed, such as the bobolink or savanna sparrow, estimating all of those parameters was not possible using this specific species approach. So therefore, the next step here is to look at using multi-species abundance approaches that would incorporate community components into our model and account for also species that have low detections. This kind of approach would elucidate which important landscape metrics play a role in structuring bird assemblages across our region. Finally, the last assessment we're looking at with regards to biodiversity and ecosystem function is a brand new project and one of my favorites. This is the use of orchids as potential indicators of forest health. So in 2019, the Changing Landscapes Initiative collaborated with Virginia Working Landscapes and the North American Orchid Conservation Center. And with the invaluable help of citizen scientists, we launched a pilot orchid survey project. We know that there are 210 orchid species in the US, with 50% of them listed as endangered or threatened. And so therefore, the combination of the ability or potential ability to use orchids as indicators of forest health with the concerns of the North American Orchid Conservation Center for individual species conservation made this a very compelling story. We know that orchids are ecologically sensitive species. They have specific requirements for soil, light, and temperature, and their distribution is also constrained by other biotic factors such as pollinators and fungi. So changes to forest habitat, particularly via changes in land use, in and or around forested areas, could alter these values in this web of relationships that impact the orchid survival and reproduction. So what we're looking at now is a new survey working with the same groups and citizen scientists, as well as students and interns, to assess and track orchid abundance and diversity across our landscape, and then relate that to variables that include landscape level metrics of forest fragmentation, patch size, etc., but also internal forest health characteristics, such as vertical structure and canopy cover. So we are excited for how this project will continue over the next year or two. All right, that was a rapid run through of our 5 years here and our program with Changing Landscapes Initiative. So what I want to get to now is just communicating a bit of how we could perceive our value in regional planning. One of them is the ability to communicate and bring people together with cross-jurisdictional collaborations. We provide a vehicle through our scenario planning framework for discussion about shared resources, and in other words, for example, water. We are a useful tool potentially for county comprehensive plans and zoning. Our information could be used to help guide and prioritize conservation efforts, which is important in this era of limited resources and time and massive amount of change. We've been working with these visualization experts in order to better communicate the value of the landscape so that planners, groups, and conservation NGOs can gain following and support from their constituencies. And then we're just going to go out on a limb here and try to brainstorm what we think our value for the National Park Service could be. We could serve as an informational, place to get scientific objective research to support parks and long-term planning using scenarios. Again, serve as a vehicle for discussion between parks and planners. Provide an objective assessment of the benefit of parks to local communities, the parks and communities immediately surrounding these parks, but also the value of the parks in terms of protecting ecosystem function and services that expand beyond immediate vicinity. And then finally, these communication tools that are backed by science. So there are 9 billion people that are expected to soon share our planet. We really need to be considering what it is that we can do in order to sustainably produce resources or maintain those resources for all of us to have a high quality of life. We've been working here in CLI to develop an approach that we hope is applicable in other systems. So what's next for us? We plan to keep working on how we can integrate our science into this Northwestern Virginia region. But we're reaching the end of, our exciting scientific discoveries here with regards to what are the new projects that we can do, what's the new data we can get, and we're really looking to expand. So we're looking for collaborators to explore scientific questions, conceptual questions with regards to landscape scale conservation or the protection of biodiversity, ecosystem function services, the integration of science to the community, spanning the boundary spanning the science policy gap, and also are there additional locations that maybe would find this kind of approach useful? So we're also looking for collaborators who may be interested in working with us on gaining traction towards larger funding opportunities in order to pursue that next level of science. We did get a few best practices from this approach so far. First, I'll go through some for the science. So integration, synthesis, and collaboration is probably the biggest lesson here for me. Integrative research brings together knowledge, capacities, programs, and infrastructure into a transdisciplinary network capable of providing understanding and solutions to complicated problems. The synthesis combines diverse concepts, including data, ideas, and information into new knowledge and understanding about ecologic change. And then collaboration provides opportunities for investigators to work together across disciplines within science or out to solve complex issues. We've also learned it's important to develop stakeholder network early on and integrate the feedback starting with data selection. The importance of using open source platforms is clear, I think, to all of you, but this has been our approach as well. We've learned that scale and context matter for understanding as well as application. And then always think about what is coming up next. With regards to communications, we've learned of the importance of collaborating with artists and designers. We need to convene an advisory board in order to help with messaging and direct us towards new collaborations. It's important to participate on local boards, to be seen, to place as much value as we can on outreach and communications, to develop relationships with planners, and that messaging matters. And finally, to connect on a personal level with people that we work with. So that concludes my half of the presentation, and I just want to thank you again for the opportunity for those listening in as well. My name is Dr. Locker. You can contact me. Here is my email, and also Carlisle Howard. And I want to give special thanks as well to Alliance of the Shenandoah Valley and the Piedmont Environmental Council for all of their help and mentorship through the past several years.
Awesome. Thank you so much, Carlisle and Yada. That was a lot to chew on there. And thanks for the question. Let's jump in. Before we do, point out real quick that Jalen Cummings at Shenandoah National Park is also on the line here and can help field any park specific questions if folks have any. But we've got a lot of questions, so let's again jump in here. The first one, what is the Smithsonian looking for in a partner, and kind of scaling this up or looking for other opportunities? What are kind of the prerequisites or kind of the best fit for doing something like this somewhere else?
Sure. I would say the first thing is the ideal partnership or collaboration would increase the capacity of all of us individually. This sharing of work and resources is really where we would all benefit. So I think, it's anywhere with regards to our communications and outreach. I don't know who this comes from, if you're a scientist or you're somebody more interested in policy, but really the first thing is let's have a conversation. We're looking for people who can contribute in terms of their skill set. We're looking for places where we could start a process or jump in to collaborate with existing processes and provide our expertise in a way that we hope would be helpful. So there's really a lot of opportunities, really just fundamentally, I think, it's making sure that we're adding to our efficiency and capacity rather than just adding additional work on people's plates.
Great. Okay, here's another one. This is great. How did this get started? How was the concept established? Partners enrolled, project scope developed, funding secured?
Yeah, I was brought on as a postdoc about 5 years ago to build a land use change model, and quickly realized that if I wanted this to be used, that I was going to have to expand what it is I worked on. So dove into communications and outreach. So early on, though, there were several people helping with funding. The Shenandoah National Park Trust was an early adopter, early funder. They gave us partial funding for some stuff. I was co-advised by a professor at Harvard Forest, so I believe some funding may have come from there. And then throughout the years, it's been, applying for smaller grants in order to do all of our field work, Virginia Native Plant Society, that kind of stuff, and then larger grants from internal funders through the Smithsonian.
Great.
Right now, we're looking
from what?
Yeah.
I'm sorry, what was that?
Right now, we're looking for opportunities for funding that would expand beyond, either conceptually or beyond this region.
Okay, great. From what organizations or communities did you receive pushback, and how did you address it?
Yeah, that's a good question. Most of the pushback comes from just me not understanding what was needed and required in terms of our capacity to communicate. So clearly, I think it's clear in this presentation as well. I'm a scientist, and Carlisle is, working on communications. So it was never pushback for the idea or for the information or the science. It was really just learning how to speak someone else's language and identifying and really communicating that you care about their needs. And that would be a fundamental part of what it is that we did. So much of the pushback we received early on was really regarding that. And now we've been finding that we're able to bridge that gap pretty successfully and trudging forward and getting our work integrated into planning. And so it's pretty exciting.
All use scientific terms when speaking to the public, and how, and if so, how do they react?
Well, I have a personal opinion about this. I think that most people are actually smarter than many of us give them credit for when we're talking like scientists. So I think it's important to give credit where credit's due in terms of intelligence and understanding. A lot of terms that I was taught in grad school are not appropriate to use are now really accepted by most of the public, such as ecology, conservation, connectivity, that kind of stuff. But I mean, really, the solution is bring somebody who has the time to think very carefully, not just about what the words are, but what they would mean for someone. And so it's not just in terms of literal dictionary meaning, but what it means in terms of context for those people that are there that you're trying to communicate with.
Yeah, that makes sense. Here's a really important question. Have any local governments made significant changes to ordinances or zoning as a result of this great work?
Not yet, but I think it's coming.
Can you speak more to that? It seems like that, that seems like so critical. You guys have put in all this work. Yep. And I mean, I assume there's different towns or communities are kind of more, like you said, kind of have the willpower to kind of move further on this. I mean, are there any, how about this? Are there any surprises with any of those kind of, as you see kind of some progress being made by some of these communities? Are any of those communities that are really pushing forward coming as a surprise, or did you kind of see those communities kind of moving in that direction from the very beginning?
Yeah. So what I mean by not yet, and I think it's coming soon, is the first step is really to there's a plan, and then there's the implementation of the plan. So we're getting our work currently integrated into plans, like comprehensive plans. So that is that's a solid, sign of initial success. And then there's obviously a delay. So I think that answers that part of the question, where I'm very positive in the movement we've made, and I see it moving forward in terms of integration into planning. Now, the other component of, is there any surprises? I just had a meeting last week with a group of utilities, and I think that there's more collaboration between conservation groups and advocates and municipalities and utilities than many of us would immediately think. The most efficient way to conserve water is, there's a cost associated with reversing decisions with regards to policy and planning and land use change. So if we can protect watersheds, protect forests in a way that works, that is obviously the most efficient way to move forward.
Great. What role, if any, have federal and state wildlife and environmental agencies had in this initiative thus far?
Federal wildlife agencies like Fish and Wildlife, that kind of stuff?
Yeah, at the state level and federal level.
Yep. Well, I communicate with a lot of people about the science. And most of that is in the form of collaboration with our biodiversity ecosystem function component. The ecosystem services stuff is, really bridges more to the policy and planning realm. But really, collaborations from, ability to go into the park and survey sites for invasive species, transects, and understanding what are the concerns with regards to land use change across, more local groups, but we don't have a lot of federal engagement with CLI, at least not yet, beyond just collaborating on science.
Yeah. One last question here. Do you work with or have you learned from other large landscape collaboration initiatives? Are there any lessons learned from them?
Yeah, I think there's been a lot of change in the past few years. Some of these groups are no longer with us, perhaps due to just funding situations. But what I've learned, I consider myself a landscape ecologist. So what I have learned from groups that I have worked with or, brainstormed with is that you can produce maps all day long, and landscape ecologists love maps, but it really doesn't. If your eventual goal is to get science off the shelf, it is ineffective. So, and then also you need a way to communicate context. So if you're a county here, for example, and you care about water quality, obviously rivers flow and they don't stop at county boundaries or jurisdictional boundaries. So how do you communicate context and the importance of that county, thinking about what their county next to them is doing and actually working with them on a greater scale? So that's the other component of landscape that I think, I've found very important and needed to prioritize over the years.
Yeah, that makes sense. Wow. Thank you so much, Carlisle and Yada, for an awesome presentation, and thanks everyone for all the great questions. Unfortunately, we don't have time to go through all of them, but just again, awesome presentation, and good luck going forward. Just hopefully we can partner with you, or if not, even just learning from some of your work and thinking about how, at least from Park Service perspective, how we can engage and maybe contribute some of the science or information to help some of these communities, connect natural resources, cultural resources, recreational resources, any of those things. That'd be great. And so there's just so many lessons learned from your work. So good luck moving forward, Yada and Carlisle. Fantastic.
Thank you. And again, if anybody wants to reach out with any additional questions, or if you just want to connect to talk about this kind of research, it doesn't have to be a solid plan. I'm really looking forward to hearing from some of you.
Great. Real quick, folks, in the chat box, I put a link to our next webinar, and it actually is going to tee off or piggyback onto Smithsonian's presentation really well. It's on May 20 at 3 o'clock Eastern Time, and it's titled Connecting the Appalachian Trail, Conservation Landscapes and Communities. And we're going to have a number of folks working on the Appalachian Trail and with some of these economic partnerships, community partnership work, a lot of similarities, again, to the Changing Landscape Initiative. So I hope a lot of you, if you're interested and like this presentation, I'm sure you will like the next presentation. So feel free to join that webinar as well. Again, our webinars are open to the public and partners. So whenever you get those announcements, feel free to, or if you see the webinar signups online, feel free to sign up for them and tell all your friends and colleagues about them. The more the merrier with these webinars. We do them to help everyone do better and more conservation work. So have at it. All right, thanks again, everyone. Thank you, Yada and Carlisle, and everyone have a great rest of your week.
Thank you, Brian.
Thank you, Brian. Thanks, everyone.
Thanks.